a table and an equation, a proportional table and proportional equation, and we're going to compare them.
Our goal is that we can compare. So we were looking at proportional relationships. We found the unit rate in like a graph. We found the unit rate in a table. We found the unit rate in an equation. Now we're going to go like one step further and we're going to start to compare. Okay? Because by the end of these next few days, you should be able to see a scenario like that on the board and tell us which one is going at a faster rate or which one is going at a slower rate. So we want to start to transition into comparisons. Like you do in English class, compare and contrast. How are they similar? How are they different? Think about comparing the situations. That's what we're focusing on today.
So this table and this equation show the rates at which two different printers print in terms of pages per minute. So we're going to find the difference between the per page rate of the two printers, and we're going to find which printer we think is faster. So can we find the unit rate?
What would the unit rate represent in terms of the printer? Like in this scenario. We know like unit rate is like comparing to 1. But for a printer, what do you think here it would represent? Giovanni, what do you think? The number of minutes for one page?
No,
How many pages per minute? Good. And really, you could compare either one, but look at how that table's represented. Is the unit rate already given?
yes,
Where is the unit rate? Or what is the unit rate for that table? It's 40. Where did Nakia get the 40 from? It's right there. Where on the table? It's the value when what? The number of minutes is 1. Perfect. So that printer prints 40 pages per minute.
Okay, so we just found the number of copies made in 1 minute using the table. We said it was 40 pages per 1 minute. So using this equation, y equals 50x. How do we think we could find the number of copies made in 1 minute using that equation?
Who remembers where we find the unit rate in an equation?
Anybody? That's Marco who knows. Where can we look in this equation to find the unit rate?
Or what number is it? By looking at the equation, do you know how many pages it prints in 1 minute? You do know. How many? For the equation, or we know the table's 40. What about the equation? It's all. Okay. It's the y when what? Keep going with that. Okay, so 50 is going to be multiplied by x. To know how many pages for 1 minute, what does our x need to be?
1.
It needs to be 1. So if we did that calculation, what would our y become?
50.
50. So how many pages does that printer print in 1 minute? 50. Besides doing that calculation, which you're right, and you all kind of contributed portions of that, where could you just look in the equation to find that unit rate? Not the table. That's a different printer. We're only talking about printer B.
And then this is printer B.
In an equation like that, where do you look? Now, we know that the unit rate is 50, so this one's not a trick question. Where in the equation would you look to find the unit rate? Because it's going to be given, if you can find it.
Well, you put you turn x into 1.
You could substitute in a value. You could say, okay, x is 1, so I'm going to do the calculation. Do I need to calculate anything to know that the unit rate of that equation is 50?
No,
No, because where do you look?
at the 50.
And where is the unit rate located? Right there. I love that. Right there. I love that you're looking at the board. We have students in other classes who don't even look at the board. Yeah, it is right there. Where, let's give a general location. Like in an equation, it's always going to be not just the first one, but where equation, we have terms, we have coefficients, we have variables, we have constants. The unit rate will always be, it's going to be next to the number of minutes. And how is the number of minutes represented? As an x. So it's always going to be next to the variable. What is a number next to a variable called? The coefficient. So in an equation, your unit rate is going to be your coefficient. So without even doing, and I love how you're going right to, well, if I know that x is 1, I can calculate it. That's a really great method. Not always necessary, especially in an equation like that, because you just see the unit rates there already for you. Perfect.
So we can actually, because it's best when you're comparing to get both of whatever you're comparing to be the same. So if we have like a table and an equation like we have right now, we either want them both to be equations so we can compare them easy, or both to be tables so we can compare them. So we're going to actually take printer B and make a table of it. So printer B's equation is y equals 50x.
Who can give us one value in that table? Go someone different. Yeah, no, what's one of them? 50 and 1. Where would the 1 go and where would the 50 go? 50 would go with pages and 1 would go with minutes. Good. Who can give another value? Jared.
2 and 100.
How did Jared get 2 and 100?
Yeah,
Okay, so he must be good. Really good. Who else? Go. 150 and 3. Perfect. One more. Why don't we're going to give you the number of minutes, and someone's going to give us the number of pages and number of minutes.
10 minutes.
Oh, I saw Eric's hand go up first. Eric.
Oh, it's 100, I think.
Do we agree? Why do we agree?
Because
Wait, did I hear someone disagree? I think I saw Kelly saying that. Do you agree that it's 500? Who agrees? Raimondo, why do you agree? Because 10 times 50 is 500. Perfect. Good. You don't have to always go in order on that table. And actually, Giovanni gave a really good example in your warm-up. He didn't just go 1, 2, 3, 4. He said 1, 2, then I'm going to try 5, and then I'm going to try 10. Or you don't have to go in order as long as you've got the information you're looking for, which is exactly in that scenario what he did. Very good table.
So here are two tables, printer A and printer B. So how can we use these tables to find the unit rate? We already kind of did it for printer A. So how do we just say it again? How do we find the unit rate for printer A?
Because the number of minutes per page. No. Pages per minute.
But specifically in this printer.
Where was it? It's on the board. I'm loving you guys today. It's right there. On any table, where do you want to look to find the unit rate? For 1, wherever that unit, that x value, which here is minutes, wherever that is 1. What if it's not provided? Let's say the first value on the table was 2 and 80. So we don't even have, what would you have to do there? Because a lot of the tables you get are going to be like that, where they don't just give you the unit rate. You almost have to find it.
divided by 2.
You're going to divide it by 2. Why 2? What are we actually using to get our unit rate?
Half of it,
Half of it, and so we're going to use
the big one.
a big 1. Yeah, we're going to use a big 1 to get down to 1. Perfect.
Okay, so for printer B, using this table, how do we find the unit rate?
Is it given?
Yes.
How do we know?
Because 1 minute, 15 pages.
Because the number of minutes provided on the table of 1 is already provided. Good.
Awesome.
And I know right now some of you are thinking like this is really straightforward, like it's just given. A lot of times it will be given like that. Sometimes not, and we'll go over examples of both. But sometimes the information is put right in front of you and it's not meant to trick you.
Okay, so now we're going to compare them the other way with the equation. So we want to find an equation for printer A. So our equation for printer B was y equals 50x. How can we write an equation for printer A? Nikia? How did you get y equals 40x?
We all agree y equals 40x.
Yes.
Why?
Because 40 is for 1, and the x is basically saying how many pages you have per minute.
Perfect. So that unit rate is going to be that coefficient. And what does the 40x mean in words?
40 times any number equals to another.
40. Okay, so 40 times any number, but in this scenario, what does the x represent?
Oh,
Pages.
The pages. Oh, I'm sorry, the minutes. The minutes, you said. So 40 times the number of minutes will equal y, which represents
any
the number of pages. So for those of you that are a little bit more inclined to like a language arts where you're better with words, where you see that y value, you can just like replace it with number of pages. And then where you see the x, you can say number of minutes. So that equation actually says the number of pages printed is 40 times the number of minutes, which makes complete sense. And on the exam, the question about like the number of t-shirts sold, like most of you understood that. You're like, well, you understand the process, so the equation's what gets confusing. You don't always have to use those variables. You can use the meanings of the variables to kind of figure it out. Perfect.
So we can actually use the tables to create a graph. How did we use those tables to create this graph? What did we do? Take a look at what's on the graph, what's given to us here. Who said that?
What did you say there? We plotted the unit rate. Where's the unit rate on the graph? Where would we find the unit rate on a graph? For 1, what has to be 1? The x or the y? And we actually want the x to be 1. Because if you think about the equation, y equals 40x, y equals 50x, that's when the x is 1. Okay, so we have our unit rates there. Are both graphs proportional? How do you know? Remember, both of them go through the origin, and what else? They're both straight lines. Great. Are you able to compare those scenarios easily when they're in a graph format? Just by looking at those two lines, what do you know about either one of those printers in comparison to the other? They're pretty close, like, and do we know that? Right there, like the lines are somewhat close. What happens like over time? Say how you said it the first way. They grow farther apart. Does that make sense in this scenario?
Yes.
Why?
Because one is going.
one of them is 10 more.
What do you mean one of them is 10 more?
One of them is always going to have more.
So like every time we increase a minute, what do we know about printer B?
We have 50 more.
It's what?
50 more.
50 more than the other one?
No, well,
It's
10
printing
more.
What did you just say? It's 10 more. How do we know that it's printing 10 more? Compared to, one is printing 50 pages in a minute and the other one is printing, or are they always going to be 10 pages apart? No, because what's happening over time? It's just going to keep growing.
Like, take a look at when both printers were printing for 2 minutes.
It was 80.
Yeah, so one's at 80 and the other one's at 100. So it's not just 10 apart, it's every minute it's growing by
Another
10.
10.
It's another 10.
If you didn't know how many pages per minute each printer was printing, and you were just asked which printer prints faster, by looking at the graph, how would you know that one printer is faster than another?
Or you go to 1 and then you go up,
Okay.
and then it says that 40 is
Let's say we have no numbers on our graph, no numbers on the axes, just the lines, the two lines. One's like this and the other one's like that. How do you know that the dark green square is faster than the light green diamond? I feel like your hand's going up. Is it going up? Why do we know that the printer B is faster than printer A? line is going higher. Right? What's another word for the line is going higher? What's the word? Starts with an S. The line is
Slow.
the line is steeper. Right? That steep line means it's moving faster at a faster rate
So it's increasingly faster.
over time. Good.
Really quick. Why does it make sense that for both of these scenarios, they would go through the origin? That both printers would go through the origin. Why does that make sense in this scenario?
Think about what the origin represents. Why does it make sense?
Because in 0 minutes they're both gonna print 0 pages.
Yeah, if no time passes, no pages are going to print. I want to know what printer is printing in no time. Like literally no time. Oh, no, we didn't. Sorry.
So, does anyone know what this word means? Slope.
We defined it. We wrote it down, I think, yesterday. Pull out your notes. Who has the definition for slope? We're going to take the definition and then we're going to say it in our own words. Wendy, what's the definition? Okay, the measure of the steepness of a line connecting 2 points. Can you explain that in your own words? We just talked about a line and its steepness. So what do we think the slope represents? Think about a ski slope.
How much is the gradient or how much is on?
Yeah, so it's really like how the line is moving. Like, is it going really fast or is it going not so fast? Is it going up or is it going down? Yeah, if it's going higher, and there's actually times where the line could be going lower, like a downward. So if you're at the top of a mountain, then the slope of that mountain is actually down because you're going to go. But if you're looking up the mountain, that slope would be considered up. So the slope is a value, it's a number. What do you think it is for printer A? And it's a number that represents how fast the line is moving. What do you think it is for printer A? What number? Just a 1, it's moving at a rate of 1. The slope for printer A is 40. What else is 40? What have we been calling it all class? We were finding it on the table, we named it. We said when we were finding that proportional relationship, we were looking for the unit rate. So we just said that the slope here is 40. We also know the unit rate is 40. And Raimundo, you actually were saying a different word. Constant of, right, so then the constant of proportionality is also 40. So what do you know about these 3 things, these 3 words? What are they always?
All the same.
They're the same. So if you know the unit rate, you also know the constant of proportionality, and you also know the slope. So again, this is one of those things where it's a newer word, but you already know how to find it, right? The slope is actually represented in a graph.
Now, when you're looking at a line, you're looking for the slope,
How it's moving.
how the line is moving.
So write this down. Write down slope, unit rate. Just write down slope and unit rate are the same thing. Because you're always going to be able to find the slope because you already know how to find the unit rate. Hands off the desk. So the slope for printer A is 40.
So what would the slope for printer B?
B.
What would the slope for printer B? 50. Because we already found that the unit rate is 50, and we know that the unit rate and the slope are the same. Good.
And how can you prove that on the graph? For every 1 1 minute that passes, our line is moving what? Let's look at printer B, the dark squares. We start at 0. For every 1 unit over, how much are we going up? 50. So that's your slope. And then again, from there, if we go from 1 to 2, for every 1 unit over, we're going another 50 up. So that's actually how you can find, we're going to talk tomorrow and next week on how to find the slope. And that's kind of like how you would do it. But if you know the unit rate and the slope are the same thing, you're way ahead of the game.
So we actually covered our
Yeah, we
thoughts on this. Yeah.
And so you said this before. The difference wasn't 50. What's the difference between the two? It's 10 per minute because one of them is 50 pages and the other one is 40 pages. So the difference between them is 10. Good.
And then we said which one was faster.
Perfect. Good.
Okay, so with your groups on a whiteboard, we're going to talk about this scenario. The price for X pounds of almonds at the snack shack is represented by y equals 6.5x. And the cost at the Nut Hut is shown in this graph. So this is the Nut Hut and that's the snack shack. Which store sells almonds at a lower unit cost and how much lower?
So which almonds are cheaper?
So we're comparing an equation and a graph.
You could either make them both an equation, you could make them both a graph, or if you want to keep them in their formats, identify the unit rate of each one and then compare them. Think about not just the number of the unit rate, but what it actually means in the scenario, because that's when this problem goes from really just math to real world application. So take like 5 minutes and together in your groups figure out the unit rate for each one. So your answer is not just the number, it's also like the scenario.